Hello everyone. In this video we're going to start talking about and finish our conversation on counting subatomic particles. If you remember, subatomic particles are the atoms, are the parts that make up atoms, the protons, neutrons, and electrons. In order for us to figure out subatomic particles, we need to use the periodic table. So we're going to use the results of the technology the results of the discoveries that we just talked about last video. So we were able to find out how many protons things have, okay? So carbon has 6 protons, hydrogen has 1 proton, sodium has 11 protons. So they know that, right? We know that. That's on the periodic table. And now according to that periodic table, we know that everything is arranged by increasing atomic number. And in class I'll show you, okay, how the atoms are arranged by 1, 2, 3, 4, 5, 6, 7, and there's no blank spaces. So the whole periodic table is arranged by increasing atomic number. So what is the atomic number? It's the number of protons. The number of protons actually means everything. You'll notice I put McLovin down here. McLovin actually it's an older movie now, but McLovin is that's the identity. So an atom's identity is the number of protons. If you want carbon, you're going to get 6 protons. If you say, you know what, I want some heavy carbon, you're still going to get 6 protons. If you're going to say, if you go up to somebody and say, you know what, I feel like some carbon today, but I want 7 protons, you won't get carbon. 7 protons now is nitrogen. Okay, now again, you need a periodic table in front of you to identify this. But the idea here, and get this in your head, that protons is the number of protons, or the atomic number, is the identity of the atom. It means everything, okay? It's very difficult to change protons. It's very difficult to change neutrons. It's not too bad. It's not too hard to change the number of electrons. So the mass number is now the mass of the atom, or roughly the mass of the atom. Okay, it's protons plus neutrons. In other words, it's the mass of the nucleus because protons and neutrons make up the nucleus. The electrons fly around the nucleus. So again, if I'm going to take the mass number, that's protons and neutrons. Okay? Now, again, I'm going to use the atomic number to figure out the number of protons. Okay? I'm going to use the mass number to figure out the number of electrons, and I'm going to go back to the atomic number to figure out the number of electrons. So let's talk about that with this slide here, okay? So isotopes are atoms of the same element. So you have to understand there's 3 versions of carbon. There's carbon-12, there's something called carbon-13, and something called carbon-14. Those are 3 isotopes of carbon. They all have 6 protons. Okay, they all have 6 protons because that's what the atomic number of carbon is. It doesn't matter what version of carbon you have, it has 6 protons. Now, because matter is electrically neutral, the pluses have to match the minuses. The positives have to match the negatives. If you have 6 protons, guess how many electrons you have to have? You must also have 6. 6 pluses, 6 minuses balance each other out to make it electrically neutral. The number of neutrons is a little bit harder to do, and it's not too bad. So if I want to find the number of neutrons, I just take the mass number and subtract off the atomic number, okay? So let's go over that. Isotopes of carbon will have how many protons? They will have 6 protons, 6 electrons, because they got to match in something called atoms. And now number of neutrons. The number of neutrons will vary, okay? It will change. So if it's carbon-12, that means there's 12 protons and neutrons. If there's 12 protons and neutrons, and it's carbon, it has 6 protons, so I just subtract and get 6 protons. Well, if it's carbon-13, now I have 13 protons and neutrons. That's what carbon-13. 13 is the mass number. But it always has 6 protons. So if I subtract the 2 out, it's now 7. So carbon could have 7 neutrons. And then if I take carbon-14, that's 14 protons and neutrons. And I subtract off the 6 protons, because again, every carbon has 6 protons no matter what. I now have 8 neutrons. So that's 6 neutrons, 7 neutrons, 8 neutrons. So it could have 6, 7, or 8. Okay? Now, when we talk about this stuff, this is actually important. Atoms, if I talk about the word atom, if I say the word atom, protons must equal electrons, period. They have to equal each other. Okay? If I mention the word ion, now that's going to happen in a couple chapters here, but if I mention the word ion, it's an atom that has gained or lost electrons. So it's an atom that has gained or lost negatives. Well, if it's gained negative, it becomes more negative. So if it's gained negative, it means it has more electrons than protons. If it lost electrons, it means it becomes overall positive. So my point is that ions, in ions, protons do not equal electrons. So just be careful. Protons do not equal electrons. More on that later. Okay? There's two ways to look at isotopes. There's something called the hyphen notation, and those numbers, I mentioned carbon-12, carbon-13, and carbon-14. Those are three hyphen notations for carbon. Notice I represented carbon-13, and those numbers are the mass numbers. Okay, so carbon-13 is the mass number. It means it has 13. In 13, there's so many protons and neutrons. Hydrogen, if I have hydrogen-3, which is an isotope of hydrogen, it has so many protons and neutrons. And the same argument with oxygen-16. Okay? The second thing is something called the nuclear symbol notation. The nuclear symbol notation has the mass number on the upper left, that's 55. Okay, so this is the mass number. And this is the atomic number. So it's always the big number here over the little number here. Okay, so now this makes it real simple. So how many protons? 26. How many electrons? It's an atom, so 26. How many neutrons? Do you know what to do? Well, if this is protons and neutrons, and this is just protons here, then you just subtract the two. Okay? 26, that's 19 neutrons, I believe. 29, excuse me, 29. 29. Okay? 29 neutrons. All right, so you just subtract those two numbers. They're all lined up for you. Okay, so going back to this, counting subatomic particles, this slide just actually summarizes it. If you have a neutral atom, protons does equal electrons. Protons equals electrons. Neutrons is always the mass number minus the atomic number. And ion, you have to add or subtract electrons, and we'll get to that in a second. Okay, more on that later. So again, how many protons? This is real simple, guys. 6. It's got to be 6. If it's carbon, it's 6. Okay? Electrons. Now, these look like carbon atoms. Okay? I haven't specified that they're ions, so it's also 3 6s. Okay? But what about the neutrons? Again, we already solved this. Well, so if it's carbon-12 minus 6 is just 6. Carbon-13 minus 6 now has to be 7. Carbon-14 minus 6 has to be 8. Okay? Let's try a different element because we already talked about that one. Let's talk about oxygen. There's 3 versions of oxygen. Oxygen 16, 17, and 18. Notice I keep mentioning the mass numbers. Okay, 16, 17, 18. How many protons? Well, there's the atomic number, 8. How many electrons? 8, because protons and electrons must equal each other in a neutral atom. Neutrons. 16 minus 8 is 8. Neutrons. 17 minus 8 is 9. And 18 minus 8 is 10. Okay? The last two things I want to talk about is relative atomic mass. And actually, I'm going to skip relative atomic mass for now, and I'm going to move on to something called average atomic mass. And this is going to be our last argument here. Okay? So, again, with average atomic mass, the average means I'm going to use a collection of things. So I noticed that carbon-12 has an atomic mass of 12. Carbon-13 has 13. But watch this, guys. Carbon-12 occupies or is present about 99% of the time. So I would think that if 99% of the carbon is carbon-12, then that number 12 is going to be highly represented in our average. Carbon-13, the heavier version of carbon, only happens 1% of the time, or about 1% of the time. So not only is number 12 going to be highly represented, but carbon-13 is a little heavier, so it's going to push the 12 a little higher. So when I look at the periodic table, the mass number is 12.01 grams per mole. I'll get to that in a moment. So notice 12 is highly represented because 99% of the time it's carbon-12. But carbon-13 happens just a little bit of time, so it pushes it a little higher with 12.01. That's our argument there for the average atomic mass on the periodic table and the mass number. Okay, so not only is that the mass number, but it's also the average atomic mass, and later that number is also going to represent something called the molar mass. Okay. Okay, I'm done with that. We will move on, and we'll talk with other things. If you have questions, email me.